All right, so what can I get done during my lunch break? Bonus hints. Given functions f of x is 9x minus 3 and g of x is 3x plus 4, find f times g. This literally means that you're going to do 9x minus 3 times 3x plus 4, and then you're going to FOIL. That is a question that every single junior should be able to do. To solve the system of equations, you have a TI-84 in front of you. What I would do is, you're going to have to do a little math on these things, but 52 plus 3z is 4x minus 16y. You're going to want to get each line in a form that says x, y, z. So this would become negative 4x plus 16y plus 3z equal to a negative 52. So we want our x's, we want our y's, we want our z's, and our constants. And you can do that with each of the three equations. And then you're going to use matrices, right? Negative 4, 16, 3, negative 52. And you're going to figure out those two lines. But use matrices. It'll give it to you. A herd of deer is introduced into a wildlife refuge. The number of deer, n, as a function of time after t years is described by the polynomial function. N as a function of time is negative t to the fourth plus 18t plus 120. As t increases, what will eventually happen to the deer population? You could probably get through this with some common sense, but I'm going to go to y equals on the calculator. I'm going to try not to give this away, but we'll see what happens. That is negative t to the fourth, so I'll use x to the fourth. I'm using an old calculator, so yours will probably look different than mine. Plus 18x plus 120. I'm going to hit zoom 6. That's a standard zoom, which only goes out 10 units. Syntax error, great. I use the minus symbol. Zoom 6. I'm supposed to use the negative symbol. That's what the graph looks like. I'm going to look up a little bit. Set y max to, I don't know, 250. So this part of the graph is meaningless. The population goes up, and then look at it. What happens to it? I can't give it away any more than that. It goes up, and then it comes down. Okay, you figure out the rest of it. Let's see, that's 6. Hint 7. Suppose that an open box is to be made from a square sheet of cardboard by cutting out 4-inch corners from each corner. It is a square sheet of cardboard. All right. I don't know anything about it. I don't know the original dimensions. Originally, this box is x by x, okay? I'm going to cut out 4-inch corners. 4, 4, 4, 4, 4, 4, 4, 4. When I do that, I'm going to create a box that looks something like this. It's going to be 4 inches tall. I took away 4 inches from each corner, which means that I took away 8 inches from each side. All right, what do I know now? I know that volume is length, width, height. The volume is 16. It must equal 4 times x minus 8 times x minus 8. And you really ought to know enough to do this. You really ought to. But that's the setup, and you can take it from there. If you don't know how to take it from there, you hadn't paid much attention. I'm not going to take it any farther than that. I gave you the equation. Figure out what the x value is. All right, the concentration in parts per million of a particular drug in a patient's blood x hours after the drug is administered are given by the function negative x to the fourth plus 13x cubed minus 54x squared plus 8x. How many hours after the drug is administered will it be eliminated from the bloodstream? Well, that's going to happen when that's a 0. So you're going to have 0 equal to negative x to the fourth plus 13x cubed minus 5x squared plus 84x. And what I would tell you guys, with as much math as you know, which isn't a whole lot, I would look at the graph just like I did in number 6. I'd look at the graph just like I did in number 6. Somewhere or another it's going to cross the x-axis. When you cross the x-axis, there is no drug in the bloodstream. And there's your hints. All right. Hope they help.